Class, welcome to lesson 4.6b. Today we're going to be taking a look at the transformation of exponential functions, and we're going to use the mapping sequence that we used back in the first or second unit to apply it to exponential functions. Before we do that, let's just revisit all the possible transformations for some of these parent functions, and you notice the last couple I actually threw in the exponentials here as well. One thing to remember, hopefully from last unit, or from the first unit, remember when you're trying to identify the A, K, D, and C, you got to be careful and watch to factor out K when possible. All right, just remember to do that, okay? So remember when we do the A is the letter that's out front. The K is the letter that's directly in front of X. D is the opposite of what you see in the bracket, okay? Oh, apologize, opposite of what you see in the bracket. And C is the number out on the end, all right? Let's take a look at this first expression. It's a quadratic, and A is going to be 2. It's out front. K is the number that's directly in front of X, which is -3. D, looking in the bracket, it's the opposite, so it's going to be -5, because remember, it's X minus D. How did a negative become a positive? It had to be multiplied by another negative. And C is +9. Looking at the second expression, ladies and gentlemen, the g at x one, it is an absolute value question. So A is what number's out in front. Okay, K is what would be the number directly in front of X here, because it's inside the brackets, and that would be 1. Okay, taking a look at D, it's going to be -3, and C is -2. If you're having trouble remembering these, folks, you can please take a moment, pause your video, go back to Unit 1 and take a look at that when we did that with the parent functions. Okay, the third one, we've got to be careful here with our h at t. Looking inside the bracket, I don't have it as x minus d. In fact, it's d minus x, but it's not factored out. So the first thing I'm going to do is factor, and I'm going to at the same time move my x or t term out front. So it's going to be -2 bracket t minus 2 closing bracket plus 10. Just remember, if you don't factor out the K, it affects your D value as well. All right, so now that we've got it factored out, A is the number out front, which is 3. K is the number that's right beside the variable, usually X, but in this case it's T, so -2. Taking a look at D, D is 2, inside the bracket, and C is the number out front, which is 10. Looking at f at x, ladies and gentlemen, that is a reciprocal function, and A is out front, which is on top in this case, so it's -5. K is going to be 6. D is -2, and C is 8. Okay, now we're moving on to some new stuff, ladies and gentlemen. These two last ones, g at x and h at t, are both exponential functions. How can I tell? Because the variable, either x or t, appears in the exponent. Okay, that's why we didn't do them with our parent functions. Okay, let's do the first one. For g at x, a is 2. K is whatever's in front of x, which would be up here, so that's going to be a 1. D is -3. And C, there's no number all by itself, so that is 0. That means that the asymptote stays at the axis on that one. Looking at this last one, we have to be careful, because when we take a look here, we haven't got K factored out. So let's factor that out first. So h at t equals 1/5 times 3, all raised to the -t plus 4. And then plus 9. So make sure to factor out your K value. So let's take a look here. A is 1/5. K is -1. D is -4. And C is 9. So that's a good warm-up, ladies and gentlemen, to where we're going. But we're going to be doing mapping sequencing. So if you want to grab 3 colored pencil crayons, let's do that. That'll help us when we do our graphs. And I want you to recall the transformation equation. And from Unit 1, we discussed that A and K deal with your stretch, compress, and reflect. Those deal with what's called transformations, shape changes. Okay, and that's what we do in the first stage, okay, or the first change. You want to call it stage 2. Stage 1 is where we do the parent function, but stage 2 we deal with the transformations. And the third one is translations, which means the shape stays the same after the A and K have been applied, but translation just means you either move it up, down, left, or right. Okay, and this is going to be the third stage or your last graph in the mapping sequence. Okay. And just remember that A and D deal with the horizontal movement, so that's why we apply them to the x coordinate of the point we're looking at. And A and C deal with the vertical movement, therefore it affects the y variable or y component of the I'm sorry, I can't talk, of the ordered pair. All right, so what's new is that that's different from other parent functions that we've taken a look at is the base changes. Okay, so in this case we want to make it how simple can this expression f at x be. Basically remove the a, the k, the d, and the c, and you're left with your parent function f at x equals 2 to the x. So what I want you to remember, it's y or f at x equals b to the x. So whatever base is given, you are going to make that as simple as you can. All right. Looking at our mapping sequence, ladies and gentlemen, again, this will be given on the test. It's the only equation that will be given on your test. Okay. So let's take a look at our expression f at x. Okay, so f at x is going to be the one that we are going to, I apologize, that should be h at x. And we just changed that in your handout, folks, to h at x. I thought I had an updated handout here, but I don't. Okay, so change that to h at x. That's going to be what's going to be our last stage here. Okay, f at x is going to be what we call our parent function, or our base function, and then g at x is going to be our transformation where we apply a and k. All right, so the g at x is going to be that change, whereas h at x is going to have all of it. Okay. All right, looking at our above expression, we notice that we have a being negative 1/2. We notice that we have k being 1, d is negative 3, and c equals negative 4. All right. And what we're going to do here is fill in the mapping sequence to help us set up our graph. Once we have our ordered pairs, we can easily graph it. Okay, so just remember we're doing a direct transference. So from here we're starting with our parent function. So looking at our parent function, which is f at x equals 2 to the x, we're not restricted in what values we need to use. So we're going to go negative 2, negative 1, 0, 1, and 2. And then you can either recall from last day's lesson what those answers are, or you plug them into your calculator or plug them into your equation. So whatever you go 2 to the negative 2, that's going to be 1 over 4. Okay, 1 over 2. 0, 1, that was your common point from last lesson. 1, 2, that tells us your growth factor. And 2 to the power of 4. So that's using the parent function. From there, we are going to use the stage 2 of our sequence. We're going to take x and divide it by k. So in this case, folks, x divided by k, if k is 1, x divided by 1 just simply stays as x. When we do y, it's a times y now, so it's going to be negative 1/2 y. The easy part is doing the x-coordinate because it stays the same, everybody. Okay. Then I noticed that the signs change for my y, so I'm going to give them all negative since they were all positive. And then I'm going to take each of those and I'm going to divide it by a half. So 4 divided by a half is 2. A 2 divided by a half is 1. And I'm just already accounting for the negative in the sign that I've already done, guys. So it's going to be my fault. It's going to be negative 1/2 here. 1/4 here, and 1/8 here. All right, and just remember, folks, when we go to the last section, we're going to take the information from here and extend it. Okay, so what we need to do is say, hey, we already have this part here accounted for as just x, so we're going to go x, and then we have to add d, but adding negative, which means it's going to be x subtract 3. And then what we have already existing, my negative 1/2 y. And then what am I going to do to that? I'm going to apply c. c is negative 4, so I'm going to subtract 4. So that's what's going to happen to my new ordered pair. So all I'm going to do, ladies and gentlemen, is take a look at my ordered pair from here and transfer it here. So I'm going to take negative 2, subtract 3 is negative 5. Okay, then I'm going to take negative 1/8 and I'm going to subtract 4. You can either use your calculator or a number line and you'll get negative 4 1/8. Okay, so just again transfer over from the left to the right and keep going. Okay, so negative 1 subtract 3 is negative 4. And negative 1/4 subtract 4 is going to be negative 4 1/4. Okay. And you can simply fill in the rest of the data points here. Negative 3, negative 4 1/2. Negative 2, negative 5. And negative 1 and negative 6. You may be wondering, hey, Mrs. R, what is this darkened line here for? What does that help us? Well, actually, the key point that I like to always take a look at when I'm graphing my exponentials is where is that asymptote? Okay, what we do know from last couple of days is that we know y equals c is our asymptote. That's what we learned. But when we take a look at our parent function, c is actually 0. So we know it's y equals 0. If we go to stretch, compress, or reflect our function, it's still going to stay where it is. So in the second stage, y equals 0. But we've got to account in the third stage for, remember, it's y equals c. So our asymptote will actually shift down 4 because c is negative 4. All right, let's sketch all 3 graphs using the same colors, and then we're going to state the domain and range of the final function, which is our h at x. All right, so I know I can't fit both of them on here, so I'll try as best as I can to keep actually I think I can. All right, so my first parent function, I'm going to start with 0 and 1. Then I'm going to go 1 and 2. That's a key point. That's telling you your doubling factor. And then I'm going to go 2, 4. Okay? And then I'm going to realize that it's going halved each time. And if I had 3, it'd be 8. So there's 4, 5, 6, 7, 8, just so I can get another point on there. Good. All right, so that is my f at x. Okay, changing color. Hopefully you've got this color coded similar or have a legend so you know which one it is. So let's do the g at x next. Okay, so what's happening here is because a is negative, it's going to reflect the x-axis, and because a is 1/2, we've got a bit of a vertical compression as well. So again, I look at my values. Okay, I'm going to start at 1 and negative 1. I'm going to go 1 and negative 1. And then I'm going to take a look at 2 and negative 2. Okay. And I also know that I have 0 and -1/2. And I know that I've got -1 and 1/4. Okay. Okay. So folks, that's my g at x. Okay. Notice that it's been flattened a bit. If you're wondering about your key points, ladies and gentlemen, sorry, key points. Sorry, let me try that over again. Boy, it's one of those days. So, key points. Okay, let's take a look what happens when x equals 1. So when x equals 1 for f at x, what do we notice? That y equals 2. That's for f at x. Okay, so what does that tell us, ladies and gentlemen? That tells us that our graph has a growth of 2. That tells you you've got a doubling factor. Okay? But what you also need to compare it, and that's for f at x, right? Just make sure that you got that color f at x for that one. But if we look at our g at x, okay, follow along our graph, instead of x being 1, x equals -1. What happens to y in that case? Y is -1. So it's half the distance that it was, half the distance away from the asymptote that it was before at f at x. So that, therefore, that tells us a equals, first of all, we know it's negative because it's flipped down, and that it is half the distance. So it's got to be a equals -1/2. All right, now let's just plot our h at x, and h at x is going to look exactly like g at x, but it's just going to be shifted down 4 and over to the left 3. Okay, to help me with this, folks, I tend to draw my asymptote in a dotted line so I know. Okay, and then I'm going to look at my points that I have. So I've got -1 and -6. I have -2 and -5. And I've got -3 and 4.5, so I know that's approaching. Okay. There. And that's my h at x. Good. So there's your mapping questions. We just need to make sure we do the last part, which is to state the final domain and range. So for h at x, okay, that's what we're taking a look at, okay? So let's try to do, instead of using y this time, let's try to do function notation, okay? So domain is such that x belongs to a set of real numbers, and range, ladies and gentlemen, is such that h at x, because that's the one we're looking at, belongs to a set of real numbers such that h at x has to be less than -4. Okay, just have to pause the video for 1 second, then I'll be right back with you. Okay, class, I'm back. Just remember that when you're dealing with your domain and range, that domain, it doesn't matter where you go, left or right. It's not going to change. It's not limited. So it's x belongs to a set of real numbers. Where the range is affected by wherever your asymptote is and your value of a, which is going to tell you if it's less than or greater than. Okay, so in h at x in this case, folks, a was negative, so it reflected the x-axis. That meant it had to be less than or equal to your asymptote. All right, let's move on to example 2, and the last one we're going to do for our lesson today. Example 2 is h at x equals 2 bracket 3 to exponent -x plus 4, and then all plus 2. First of all, hopefully you notice that, hey, Mrs. R, don't trick me. I haven't factored out h, or haven't factored out k in this case. So let's rewrite that factored out. So h at x equals 2, that stays out front, and then we've got 3 raised to the negative x minus 4, and then that's all going to be plus 2. All right. So you may wish to add in a separate set of brackets, so you could do that, or it could look like this. You could go 2 to the 3 negative x minus 4, and then a separate set of brackets here, plus 2. So I'll accept either version of that, whichever one you like and which makes more sense for you. Please feel free to use it. All right. So to figure out our base function, f at x, we're going to strip away the a, the k, the d, and the c. And what are we left with? We're left with f at x equals 3 to the exponent of x. All right, map the key points. Again, we're going to use the sequence. So based on our new factored formula, a is going to be 2, k is going to be negative 1, d is 4, c is 2. And we already know our parent function is 3 to the exponent x. So let's apply the mapping function this time. Okay, again, we're going to use the same values for our parent function. So we're going to go negative 2, negative 1, 0, 1, and 2. And when we plug those into our y value this time, I start with 0. So anything raised to the exponent 0 is 1. 3 to the exponent 1 is 3. 3 to the exponent 2 is 9. And then I know that it's the opposite patterning of a fraction the other way. All right. Okay. I also know that, hey, this is my asymptote. So we're going to follow that as we go through. Taking a look at our second stage, which is our transformations, which is our a and k, we're going to say, hey, I've got x, and I've got divided by negative 1, which is the same as negative x when you've divided through, because you don't leave it as a denominator. And then you've got a times y, so a is 2, so we're going to have 2y. This isn't that bad today. For this example, I like it actually, because when you change the sign, it's going to be 2, 1, 0, negative 1, negative 2. Okay. And then when we go to do this, you're just multiplying your y expression by 2. So if we start at the bottom, 9 times 2 is 18. 3 times 2 is 6. 1 times 2 is 2. 1/3 times 2 is 2/3. And 1/9 times 2 is 2/9. Okay, and again, when we apply the a and the k to the y asymptote, it doesn't get affected by that because it's affected by c, which is your vertical translation. All right, last stage, folks, is stage 3. We're applying the d and the c. So you stay what we already have, which is negative x, and we're going to add 4 because that's what d is. And then we take a look at what we already have for ay, which is 2y. And then we're going to add, my fault, c, which is plus 2. All right. So we're taking our answer from here. We're just adding 4 to the x, which makes it easy. So you're going to have 6, 5, 4, 3, 2. Okay, that's pretty good. And then you're going to take each of your 2 y's and you're going to add 2. So if you got 2/9, you add 2 to it, it's going to be 2 and 2/9. Okay, if you've got 2/3, it's going to be 2 and 2/3. And then 2 plus 2 is 4, 2 plus 6 is 8, and 2 plus 18 is 20. Now what we have to remember here is to do our asymptote, and it's going to be y equals your c value, which is 2. So just quickly for my labeling, this is my f at x, which is my parent function. I'm going to call g at x my transformations, and I'm going to call h at x, which is the entire thing. It's got translations and transformations all put together. All right, let's transfer this over to the graph, ladies and gentlemen. Okay. So let's start with our parent function f at x. I'm going to always start with my whole numbers first, so I'm going to go 0 and 1. I'm going to go 1 and 3. Again, that tells you got a growth factor of 3, and 2 and 9. So there's 4, 6, 8, 9. Okay, and again, if it's steeper rate of change when it's increasing, it's also decreasing at a steeper rate of change here. All right, so there's my f at x. All right. Doing my g at x, ladies and gentlemen, it's going to look a little different because remember, k is -1. So in fact, it's going to reflect the x-axis, but we also have a horizontal stretch that's taking place. So watch what is interesting here. When I start at my, if I take a look at my original y-intercept, it used to be 0, 1. Now when I go to my g at x, it's 0 and 2. That tells me that it's been stretched twice, but I'm also going to notice a trend is that it's going the other way. So when I go to plot the rest of my points here, if I go -1 and 6, and -2 and 18, which is way up here, and then I go to my fractions here. So if it's 1, it's 2/9 and 2/3. Sorry, my fault. -1 and 2/3. Sorry, 1 and 2/3, and then 2 and 2/9. Okay, good. So that's my g at x. Let's just take a look at some important points or the key points here. Okay, so when we have f at x, and we have x equals 0, sorry, x equals 1, we have y equals 3. Basically, that tells us we've got a triple factor, or a factor of 3. Okay, but what happens, or that gives us the base of 3, if you want to argue that, yep. Okay, but what happens when we go to our g at x? Instead of, if you follow along here, folks, instead of x being 1, it's now -1. So x equals -1 and y equals 6. Okay, so notice first of all that since it's negative, we have a reflection of the x-axis. I apologize, reflection of the y-axis. Okay, so that tells me k equals -1, which reflects the x-axis. My fault, y-axis. I think I said that again. Sorry, guys. And then what I want to note is the difference between y equals 3 and y equals 6. It's twice as big, or twice as large, right? So what does that tell us? That a has to equal 2 because it's been stretched twice as much in the vertical direction. Okay? Good. Those are good key points to remember. Let's now finish off our graph with our h at x. Okay, so for h at x, we know we have an asymptote at y equals 2, and we are shifting it up 2 and to the right 4. Okay, so order 220 you can't get on, but 3 and 8 you can. So we'll go 4, 5, 6, 7, 8, and then we've got 4, 4. And then we've got 5, 2 and 2/3. And that's our h at x. All right, let's finish off by doing our domain and range. So domain is such that x belongs to a set of real numbers, whereas range, h at, sorry, forgot my lovely marks here, so let's start that again. So range is such that h at x belongs to a set of real numbers such that h at x has to be, in this case, guys, it has to be greater than 2. Great. So ladies and gentlemen, I would like you to see the handout that's next page on our lesson here. And I would like you to try doing questions 3, 5, and 7, and then try graphing them as well. If you want to give yourself a challenge or one question where k is not factored out, you can give yourself a try on the last question on 8. Give that a challenge if you'd like. And don't forget to state the domain and range after you've mapped your 3 graphs. Here ends today's lesson of 4.6b, Graphing with Mapping. Have a great day, folks, and as always, come see me if you need some extra help. Goodbye.